Okay, so we're given a difficult integral to evaluate, and it's improper. So if you were to rewrite this as a proper, I'm sorry, as an improper integral, you'd have to do it with limit. So it's limit, and at 0 is not a problem because the cosine of 0 is 1. And then the cosine remains positive until it hits pi over 2, and then it becomes 0, and the natural log of 0 goes off to minus infinity. So I'm going to say over here A, and I'm going to say A approaches pi over 2 from the left side of the natural log of 2 cosine x dx. This is a rather difficult integral to do, by the way. However, it is related, which I was surprised to learn, to this over here, the basal identity. And we're going to revisit the integral later on, but right now we just want to proceed assuming that our limit does exist, by the way. I just want to talk about the picture of it, and the picture of this thing over here, looking at it. I'll scroll to that. This is the picture over here, and this is the integration we're doing over here. We're trying to do this integration over here. I'm seeing this, and again, this thing is shooting down over here, as we know, because of natural log, all right? So the thing about this one over here, looking at it, you get some idea that there's an area there, all right? We're trying to figure out what that area is. Let's go through the work, and to do the work, I want to point out the first thing I did with this problem over here was I split it. I'm using the rules of logs to do that. So the log of this number here, which is the product 2 times cosine x, I'm going to write as a sum, all right? This first integration is incredibly easy to do, by the way, and that's going to be 0 to pi over 2, the natural log of 2 dx. What does that integrate to? The natural log of 2, integration from 0 to pi over 2. And what do you get there? You would get pi over 2 times the natural log of 2. And I'm going to bring the half up, and that's going to be pi natural log of root of 2. And that's where this is coming from, right over here. All right. Then I'm stuck with this one over here. All right. So what I did with this one over here is, I'm concentrating on this guy here now. So this is the guy we're going to concentrate on. All right. How do we do that? Again, I know it's improper. I'm just going to make a u substitution and see what happens. And the u substitution I'm making, just to outline that for you, is this over here. And then certainly rearrange it a little tiny bit. You get this over here, and dx equals d minus du. So what I want to do is I want to write that down for you, just to verify what we're saying is true. That's cosine of x dx. So let's just rewrite that. And when x is 0, u would be pi over 2. And when x is pi over 2, u would be 0. Natural log, cosine, and what's x? Well, x is pi over 2 minus u. And what's the du? What's the dx is minus du. I'm going to rewrite this a tiny little bit. Before I do that, though, I want to point out that's written right over here. All right, I'm just going to rewrite this a tiny little bit. Change the, because it's, minus that integration. So reverse the limits on the integration. And then natural log, and the cosine of pi over 2 minus u. Let me write this down for you. These are what's known as cofunction identities. Is the same thing as sine of u. And these are identities that you learned in Math 120, or in a course in pre-calculus. So I'm going to write that down, natural log of sine of u du. All right? That's written right over here. Now, this is kind of remarkable that this integration here is identical to this integration over here. They're identical integrations. So what I did was I just wrote that down over here. All right? And then what I did, I said, if that's true, I'm saying 2 of these things would be 2 of these things, this over here. All right? Remember, this thing here and this thing here are identical. All right, let me go backwards. Let me just start to erase. All right, so all this business over here. Now, granted, you may lose track of what you're trying to do, by the way. I want to point out what we're trying to do over here. We're just trying to get this. And it's going to be a long road to get that, by the way. So let's keep moving. And I got this over here. The next thing I certainly notice is that, this here certainly is true to this over here. And then I just use this identity that we know about now to rewrite this like this. All right. The next thing I do is I pull those two integrations together. I get this over here. Pretty easy to do, by the way. And then I kind of use the rules of logs again. And use the rules of logs again, you're going to get, the product. That sum turns out to be a product now. This looks somewhat familiar to me, so I'll write down what I'm thinking I'm saying. So remember, it gets from pre-calculus, the cosine. Nope, I don't want cosine. I want sine. Let's write this over here. The sine of 2 theta was 2 sine theta cosine theta. And I would divide both sides by 2, so sine of 2 theta over 2, same thing as sine of theta cosine of theta. And that's all I did over here. So I noticed I had that, the double angle formula, so I wrote it down, all right? So again, we're using this over here, all right? And then what I did with that was I started to realize I could separate that, all right, using the rules of logs again. And what do you get? You get this over here, and you get this over here. And again, we just did that, all right? We just did this one. What I mean by that, let me get my eraser out. I'm just kind of following along with what we've done so far. All right, and again, we have this over here, but I want to point out we've already done this, and that turned out to be this over here. All right, but I still have this nightmare to deal with here. But I still have this one. Let me get my eraser out, and I'm going to concentrate on what I'm really worried about now. I'm worried about doing this guy. All right, so what we're going to do is we're going to proceed along, and we're going to try to do that guy now. All right, so where's that guy go? We're going to do this over here. How do I do that? Another U substitution, and it just seems to be endless, by the way. So let's write this down, and I'll write on the side for you just to verify that what we're saying is true. And we got this over here, 0 to pi over 2, natural log of sine of 2x dx. I'm saying u is equal to that, and d equals that. So let's write this down over here. What are you going to get? Well, if x is 0, you still get 0 here. And if x is going to be pi over 2, 2 times pi over 2 is pi. Then you can get the natural log. Well, the sine, and 2x is equal to u, so I'll put this over here. And what's dx equal to? Dx is actually equal to 1/2 of a du. So I'll write this 1/2 over here, and the du over here. Let's tell you where this is. That's written right over here now. All right? So we're pretty good with that. And then what I'm doing over here is just, kind of looking at it. And I noticed that the limits now go from 0 to pi. So I'm going to split into two different parts. I'm going to go from 0 to pi over 2 and pi over 2 to pi. All right? So what am I doing over here? Let me get my eraser out again because I'm moving forward. And I'm looking at this guy over here, and I recognize this guy again. What do I recognize him to be? This guy here. And again, if you can't recognize him, you go back and you start to realize that it's really this guy over here. All right? So what do? I just write that down. Whoops, where am I? Right over here. But then I'm still stuck with this guy. All right, I'm stuck with this guy. All right, let me get my eraser out, and we're going to concentrate on that guy now. Again, this is a lot of moving forwards, but as we move forwards, we have to move backwards, and we may forget where we were, and that's why we write things down, by the way. So I want to do that, and I'm writing that over here, by the way. All right, so what I did was I made another substitution. All right, substitution all over the place. I said this, and let's change the limits of integration now. All right, let's write that down. So I'm taking this guy over here, and I'm making that substitution. And what would you get over there? 1/2. Well, let's see. If x is equal to pi over 2, u would have to be 0. Again, I'm using this over here. And let's see. If x is pi, u would have to be pi over 2. And then what do you get? You get the natural log of the sine of u plus pi over 2, and then du is equal to dx. All right, let me tell you where that's written. That's written right over here. All right, so I'm pretty comfortable with that. And I'm kind of looking at that, and that's sort of familiar to me, but sometimes you can forget things. So I want to go through, if you forget something, you probably want to write something down then. And what am I going to write down? I'll write down, I'm looking at this sine of u, and it's not a cofunction identity, but it's sort of like, related to that. But I'll write this over here. I'll write this as sine u times cosine pi over 2 plus sine pi over 2 times cosine of u. Well, the cosine of pi over 2 is 0, so this term disappears. And the sine of pi over 2 is 1, so this turns out to be just the cosine of u, all right? And that's where I have this written over here, by the way. So we just jump from this to that, all right? What am I going to do now? I'm looking at that, and, certainly it's easy enough to write that down. I wrote it down. Oh, what I did over here was I wanted to put back to the land of x's, which is trivial. I mean, it really is. What do you do to do this over here? U equals x, du equals dx. And we're using u's a lot, by the way. So I want to tell you where we are now, but again, I may forget where I need to go. All right, so I want to point out where we are. We now know this is equal to this. All right, so you kind of work your way backwards. All right, so someone says, work your way backwards to what? I want to work my way backwards to the original problem, by the way, which might be a long way to get there, but I have a lot of things done, and I want to be able to get back there. So let's take a look what we got. So first thing I would do, I write this down over here. Now let's say you can't remember that. But you go back in the notes, and you see that written down somewhere. And let's see where that's written. Well, I got that written there, right? So I have it written over here. And let's just look back over this thing over here. And, I said it was equal blah, 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 this thing over here. All right? And then you kind of went through steps, right? What were the steps you went through? Well, let's write this down. I got this over here. I'm seeing that. We did that already. And then I did this business over here. What did it turn out to be? This guy over here. So that's all I did. I plugged it in. All right? Then, kind of looking at it, you could add those two together. Right? What do you get over here? You get this over here. All right? It's kind of remarkable. All right? That this here, let me circle it, actually turned out to be this over here. All right? So what am I going to do now? I'll go work backwards. And working backwards, and so where are you working to? Well, I guess we're working back to a place where we need to figure something out. So I'm going to say we need to figure this thing out over here. Now, someone's going to be working backwards. Do I see that anywhere? And I'm pretty sure we see that somewhere. We see that right over here. All right, so two of that integrations, all right? Let's go back over here. And what's that equal to? Let's take a look at that. All right, so I'm going to say it equals this over here. All right, let me go backwards. I'm seeing that right over here. All right, I'm seeing it. All right. Again, we're just working our way backwards. And then the question comes is, am I seeing, these things in the problem? And I am. And what am I seeing over here? I'm seeing this thing. And where do I see that thing? I see that right over here. And all I do is I write it down now. All right? So I write it down, and I'm seeing this over here now. And then what do I do? Well, what I do is I notice that on each side of the equation, it's this integration that I don't know. On one side there's 2, the other side there's 1, so I just subtract it from both sides, and I get this over here. And now I know the value of that integral, all right? So what do I do now? I keep going backward, all right? And where am I going backward to? I guess that original problem we had, which is way up here. So, what's way up here? And I want to point out we're trying to do this integration over here. And we have it written down here. And I know it's this thing plus this thing. Well, again, I'm working my way backwards, and we just determined what this is. So what do? I plug it in. All right, let's keep going. I know it's a lot of scrolling, by the way. So I got this. Let me just make sure I'm saying that right. We're doing this over here now. We had this plus this. What was this thing over here? It turned out to be this thing. We just did that. What does this give me? 0. So now I know my integration. The original integration over here. That this integration that they asked me to do from 0 to pi over 2 ln 2 cosine x dx is equal to 0. All right? Let me just go to the end of it. And I want to point out to you in the end of it, this picture over here, this area there, positive area, negative area. They're equal areas, by the way. In other words, this area here is actually equal to this area over here, but it's a negative area, positive area. It'll sum to 0. All right? Thank you.